Welcome to our paper towards an open source verification method for Chisel and Scala. I'm Martin Schoeberl. I'm Associate Professor at Technical University of Denmark. This work has been done together with two students, Simon and Yul from Technical University of Denmark and Richard as grad student from UC Berkeley. So what is the current state of the art and hardware design and verification? So most hardware designs are still in VHDL and Verilog, and those languages are, let's say it, quite old languages. They feel for a software engineer almost like programming in Fortran. All these modern concepts such as object-oriented programming or functional programming are missing in these languages. There is now System Verilog, which adds object-oriented programming for verification. And it also adds code coverage and constrained random generators, which makes it actually quite a complex language. I mean, ending up being 250 keywords in the language roughly, and still supporting all legacy Verilog up to the object-oriented verification methods. Sadly, object-oriented programming is not available for a design description. It's only available for verification. On top of System Verilog, actually, the universal verification method has evolved for verification. This short UVM is a collection of open source Verilog, System Verilog classes. It is considered an industry standard. Adaption, I don't really know how much it is really used. I've done some questionnaires in Denmark. There's quite some hardware companies here in the greater area of Copenhagen, and all are stating they're looking into UVM, but not really using it already. Anyway, UVM is a kind of blueprint to define your tests. The idea is to make tests reusable. And the main approach is actually to compare your design against the reference model, using then System Verilog constrained random test vector generation to drive your hardware description and your reference model, and having a scoreboard comparing those, and also have using System Verilog code coverage metrics. What we are looking at is actually Chisel and Chisel test. Chisel is a relatively new hardware construction language, evolved from the University of California in Berkeley, is now also considered a lot of development from Sci5 and IBM. Chisel itself is embedded in Scala, which itself runs on the Java virtual machine. So basically, you have the whole world of Scala and Java libraries available for your hardware construction and also for your hardware testing environment. For example, if you're testing a processor and you want to read an ELF file, you might find a Java library to read an ELF file. Basically, Chisel generates Verilog for synthesis. So it uses Verilog as an intermediate language, so we can use all tools available. And as Chisel is part of Scala, it is an object-oriented language with functional programming. So we can use object-oriented programming to describe your hardware. You can also use functional programming to describe your hardware. Chisel test is actually a testing framework for Chisel written in Scala. So basically, it sets inputs and reads outputs of a device on a test. What we are looking at, the missing part, the link for a full verification framework, we would like to do an UVM-like verification framework in the Chisel Scala setup. We also need a mixed language support. Of course, you have all the legacy code written in Verilog and VHDL. Verilog is easy for Chisel because you can have black boxes with Verilog and then using Verilator to execute this Verilog code. But we are also looking at how to integrate your VHDL code. In Europe, we have more VHDL codes than Verilog code. Constrained random generation, we're looking at coverage measurements. The question is, where do we do the coverage measurement? Is it on the Verilog generated Verilog or in the intermediate representative Wordle, or is it in Scala? The question is always, when you write hardware generators, what Chisel is more, then what is the code coverage? And of course, we need a bunch of library for test components like bus function models and this kind of stuff. So we started out looking at this one with a small example using Chisel and UVM on the same test circuit. It's actually an ALU with an accumulator. It's a very simple circuit, but okay, it's an ALU for a combination circuit, but it also has states with an accumulator. It is written originally in Chisel for a small processor project, and we also rewrote it in VHDL to see how we can drive this one. And we wrote tests for this circuit with Chisel and UVM. And we're using Yosis to convert VHDL to Verilog. And then we can test the VHDL implementation with Chisel. So we can use the same testing environment now for our Chisel implementation and our VHDL implementation. Give you a quick show on this one. Okay, this is a Chisel implementation of this simple circuit. Can do some basic arithmetic logic operations, and it also having a register. We have rewritten the same circuit as VHDL code, you can see here. Then we are able to test this circuit, both circuits with the same testing. So this is a testing actually as a reference implementation Scala, and this testing is poke and peek, and we're actually doing not really constrained random, but we have some corner cases and some random cases here. And then we are running those tests for those values. And you see, we are running one of the tests for the Chisel implementation and the very same tests actually for the VHDL implementation. And yes, this is a way how to run tests in a Scala environment with SPT tests. This is the first one is now running the Chisel test, and okay, it's a little bit too fast. The first one was running the Chisel test, including a coverage report. We're having a coverage generator here as well. And the second one is generating C code, using Verilator to generate C code and then compile this C code and running the very same test from a Scala Chisel environment, including the coverage report for the VHDL version. In conclusion, for this short presentation, we have a project just started up. First results I've shown here on open source digital design and verification framework. Chisel is a good starting point as a language, and we aim to extend Chisel test with verification tools in Scala. Using Scala, Verilator, and Yosis, all open source tools. So as I say, that's an open source ongoing project, and you have a link here to the source, and very welcome to join the effort. And thank you for watching this short video.